present now.
Miss Northwood.
Yep.
Sydney's coming. She's
Yes.
having a problem with her computer.
Okay, thank you.
No problem.
Okay, I'm just getting the document camera loaded up. Okay, can everyone see? See in here?
Yep.
Yep. Okay, thanks. All right, so we're starting a new unit today. It's still very much related to quadratics, but it's our factoring unit. Factoring is probably one of the most important things I'm going to teach this year that you're going to use in grade 11 and 12. And it's going to take place over the next 3 days. So each day there'll be a live lesson in the morning and then a different type of factoring in the second lesson. You really need to watch the videos. You really need to get all the types of factoring learned and recognized. And I'm going to help you with that along the way. But please make sure you do everything so that you have this down. It'll make grade 11 a lot more smooth for you. So our learning goals for this morning are learning to divide a polynomial by a monomial term by term. That uses exponent laws. It's pretty straightforward. We're going to learn to common factor a polynomial expression. So common factoring is really important. And hopefully by the end of the lesson, you'll understand how to do it and you'll feel comfortable with it. And we're going to learn to common factor a polynomial expression by finding the greatest common factor, which you may have heard when you were in elementary school relating to numbers, but now we're going to do it with algebraic terms. And we're learning to apply common factoring to changing between standard form and intercept form of a parabola. That in grade 10, that's the reason we learn factoring, but there's a lot of other purposes for it, as you'll find out when you get into grade 11 and 12. So to divide a polynomial by a monomial, you divide term by term. So we're going to find the quotient. And the reason we're doing this is because it's going to help us with factoring, okay? So if you divide 25x squared plus 10x by 5x, it would be the same thing as dividing each term by 5x. And then when you divide 25x squared by 5x, you divide the 25 by 5, which gives you 5. And then x squared divided by x is just x. But you could also think of it using the exponent laws, where you keep the base and subtract the exponents. And the exponent on this x in the bottom would be a 1. And x to the 2 minus 1 is 1. Okay? You might remember we did our little unit on exponent laws in one day. And then here we have 10 divided by 5 is 2, and x divided by itself is 1. Or if you go to the x divided by x is x to the 1 minus 1 way of thinking, we know that anything to the exponent 0 is 1. So now that you know that, you can divide term by term. You don't have to write that out. You can just think to yourself, okay, I'm dividing this term by this, and then I'm going to divide the second term by the denominator. So if you divide 4xy by 2x, you do 4 divided by 2 and you get 2. X divided by x gives you 1, anything divided by itself. And then, so I have 2y minus, and then I'm going to divide 2x squared by 2x. And so I'll get 2 divided by 2 is 1, which I could write down or I don't have to. And x squared divided by x is x. So I'm going to give you a minute to try this one. Try to divide each of these terms by 3x, and then I'll put the answer down, or I'll ask one of you actually for the answer. Anyone think they've got the answer for 9x cubed plus 27x squared minus 3x divided by 3x? Unmute yourself if you think you know. Nobody? All right. How about just 9x cubed divided by 3x? Anyone think they know that? Okay, hopefully you can hear me. 9 divided by 3 is 3. X cubed divided by x would be like x to the third divided by x to the 1, or x to the 3 minus 1. So that's x squared. And then plus. So now we're thinking of 27x squared divided by 3x. 27 divided by 3 is 9. X squared divided by x is x. And then the last part's probably the trickiest one, or the one that people forget about the most often, because you're dividing 3x by itself. And whenever you divide something by itself, you get 1. So the most common mistake with C would be to forget the minus 1 there, but you need it, because 3x divided by 3x is 1. Okay, for D, so 6AB divided by 3AB is just 2. Minus 3 divided by 3 is 1. A squared divided by A is just A. And B squared divided by B is just B. And then for this one, 15y squared divided by 3y. Actually, I'll give you a minute for that one too. See if you can get it. Anyone think they've got E? No? Okay, 15. Oh, okay, go ahead. Yeah.
Wouldn't it be 5y minus y2?
Yes, very good. So 15 divided by 3 is 5. Y squared divided by y is y. Minus 3 divided by 3 is 1. Y cubed divided by y is y squared. Very good. So if you forget your exponent rules, that would be y squared. Awesome. Okay, so now we're going to start factoring. To factor means to rewrite a sum or difference of terms as a product. It is the opposite of expanding, okay? When you factor an expression, you actually find an equivalent expression. So you're just writing the same thing differently, okay? So you're not finding something that's not equal, you're finding something that's equal, but just written differently. So for example, if you expand 2 times y plus 3, you use the distributive property, and you get 2y plus 6 by expanding. What we're going to learn is how to start with 2y plus 6 and factor it to end up with 2 times y plus 3. And we know that these are equal to each other. So expanding and factoring just create equivalent expressions. Grade 9, 10, we focused on expanding so far. Now we're going to spend the next 3 days focusing on factoring. So going from this, which are terms that are either added or subtracted, to at least a product here. So 2 times something. Okay. So how many different equivalent expressions could you find for the expression 12x squared plus 60x that are the product of factors? So I'm going to start us off so that you kind of get what I mean here. So I could write this as, if I know 12 goes into 60, as 12 times x squared plus 5x. And the reason that that's true is because if you expand it out, so if I do 12 times x squared, I get the 12x squared back. And if I do 12 times 5x, I get the 60x back. Is there another way that I could rewrite this as a product? This part's interactive, so if you can think of another way to write it as a product, please give it to me. There's probably about 10 ways you could write this one as a product.
Wouldn't you just change the thing in front to like a, let's say like a 6 or something, and then
Yeah,
yeah,
perfect.
like a
So if you-
3, 2 or something, just something like.
Okay, so we've got 2 ideas here. If I change it to a 6, then 6 times what gives me 12x squared? That would be 2x squared. And then plus 10x. If I changed it to a 3, 3 times what gives me 12x squared? That would be 4x squared. And plus 20x. Awesome.
I wrote 4 bracket 3x squared plus 15x.
Yeah. Another one. Anyone got another one?
Two bracket 3x squared plus 15x.
Close. It would be, if the 2's out front, then you need a 6.
Sorry,
It's 2
it's
times-
30. It's 30.
Yeah.
I read the wrong line.
Perfect. Okay. All right. So there is actually one called that involves the greatest common factor. And I'm going to write that one down and you're going to tell me how it's different. So the greatest common factor, if I write that in front, is actually 12x. And then what would go in the brackets would be x plus 5. So the reason that it's called, the 12x is called the greatest common factor is because now when you look in the brackets, there's nothing in common between x and 5. Whereas if I look back here, 6x squared and 30 still both had, the 6 and the 30 had 3 in common and they both had x in common. If I look back to this one, they both had 3 in common and x in common. If I look back here, they both terms still had 4 in common because 4 goes into 20 and x in common. Here, if I look back, they each had 2 in common and x in common. And here, if I look back, they each had x in common. But if you choose the greatest common factor for your first term or your term out front, then what's inside, the only thing they'll have in common will be a 1, okay? And that's called common factoring. So that's what we're going to learn to do. So that instead of coming up with multiple or each of us coming up with a different answer, this is going to be our answer because we're going to choose this term here to be the greatest common factor or the GCF. Okay. So the greatest common factor of a group of terms is found by, so first of all, you want to find the biggest number or greatest common factor of the numbers, sorry. And that's the largest number that divides evenly into all of the numbers. So if you were looking back at this as an example, we'd be looking for at the 12 and the 60 for the biggest number that goes evenly into both 12 and 60. And that number is 12, because 12 goes into itself and it goes into 60. And then the second part of your greatest common factor is finding the greatest common factor of the variables. So if the variable appears in all of the terms, so if you see here, X was in both terms, okay, it was in both terms, then choose the one with the smallest exponent. So I have an X squared and an X. So for my greatest common factor, I'm choosing the X to be part of my greatest common factor. And that's because you can divide 60x by 12x without getting a negative exponent. Okay, so you never want to, you can't think of X going into, or you can't think of X squared going into X, because then you'd have a negative exponent occur, which you don't want to. Okay, so we're just going to practice right now finding the greatest common factor of a group of terms. So if these are my three terms, the GCF is going to be, so first I look at the three numbers, 15, 5, and 10, and I want the biggest number that divides evenly into all three of them, and that's going to be 5. 5 goes into itself once, into 15 3 times, and into 10 twice. Then I look at the variable parts, so I've got x cubed, x squared, and x. X is in all three terms, so it's part of my common factor. I just need to know what exponent to put on, and it will be the smallest exponent, which is just a 1. So my greatest common factor would be 5x. Those are the rules. So for B, the greatest common factor, so first look at the numbers, 1, 2, and -4. So 2 does not go into 1, it does go into -4, so 1 is my greatest common factor for the number parts, which I don't need to write down if there's a variable in common. And then if I look at the variables, they all contain A. And the smallest exponent on a variable part is just a 1, so the greatest common factor is just going to end up being A. Okay, so for the next one, to figure out the greatest common factor, you look at the three numbers and figure out the largest number that goes evenly into all three, and that's going to be 3. Then I'm going to look at the x's first. There's an x in every term, so x is going to be part of the greatest common factor. And we want the smallest exponent, which would be just the x to the 1. Then we're going to look at the y. It's only in one of the terms, so it can't be part of the greatest common factor. So our greatest common factor is just 3x. And our last one, we'll look at the numbers, 20, 5, and -30. So the biggest number that divides evenly into all three numbers is 5. Now we're going to look at the A's. There's an A in all three terms, so it's going to be part of my greatest common factor. I want the smallest exponent, so that's going to be A squared. And then B's, there's a B in all three terms. And so it's going to be part of my greatest common factor. The smallest exponent on B is B to the 3rd. So my greatest common factor is going to be 5a squared b cubed. All right, so to common factor, you must determine the greatest common factor of the terms and then mentally divide each term by the greatest common factor. So we're going to try this factor to rewrite like we did, like we were looking here. Okay, so we're gonna try, we're starting with this and we're factoring to end up with something that looks like that. Okay. So first of all, we look at our two terms on this side and we look at the numbers. So the greatest common factor of the numbers is 5. And then we look at the variables. There's an x in both. And the smallest power of x is 1. So there's our greatest common factor. And now we want to figure out what goes in the bracket. So in order to do that, there's two ways of looking at it. What do I need to multiply 5x by to get 5x squared? That's the way I usually look at it. What do I need to multiply 5x by to get 5x squared? And that's x. And then I could check 5x times x is 5x squared. The other way to look at it is if you don't know what you multiply 5x by to get 5x squared, then you just kind of think of dividing 5x squared by 5x. And if you do that, you'll get x. And then same thing here. What do I need to multiply 5x by to get positive 15x? That would be positive 3. And then you can check 5x times positive 3 is 15x. If you weren't sure, then you could think of dividing in your head 15x divided by 5x, and that would give you 3. Okay? So what we just did there was called common factoring. We can do a check, which is to expand using the distributive property. And you should get back what you started from. And the other thing that's good to check for is what you're left with in the brackets doesn't have anything in common, okay? Because sometimes you could accidentally not choose the greatest common factor, and then the terms inside the bracket would still have maybe 2 in common, or they'd still have an x in common, right? So that's the idea behind common factoring. I think we're just going to try a bunch now. So here we have our first question is factor and check. Okay, so we're going to common factor and then check our answer. So I'm going to work down vertically, but I'm still going to look at first of all, the number. So 1 and 2, the greatest common factor is just 1, which I don't need to write down. But then they both have an x in them, both terms. So there's going to be an x in the common factor. And then smallest exponent is just the 1. So then what do I multiply x by to get 1x squared? X. And then what do I multiply x by to get positive 2x? Positive 2. And then we can do a check. Check by expanding. So x times x is x squared. X times positive 2 is positive 2x. So same idea here. I'm going to check the coefficients or the numbers first. 3 and 6. Biggest number that divides evenly into 3 and 6 is 3. Then I'm going to check my variables, but there's only an x in one of the terms and not both, so it's not common, so it can't be part of the common factor. So I open up my bracket. What do I need to multiply 3 by to get 3x? X. What do I have to multiply 3 by to get positive 6? Positive 2. And again, if you don't know that, you can mentally divide 3x by 3 to give you x, and mentally divide 6 by 3 to give you 2. And then we can do a check. 3 times x plus 2 is 3x plus 6. Okay? All right, so now we're just going to factor. So I'm going to give you a minute to try the first two, A and B, and then I'm going to take them up. So first you're looking to find the greatest common factor. And then you're trying to get what goes in the brackets by either what you need to multiply by or by mentally dividing. Does anyone think they know just the greatest common factor for A?
$15x.
Yep. So 15x is the greatest common factor. And then what do I need to multiply 15x by to get 15x squared? X. And what do I have to multiply 15x by to get negative 30x? Negative 2. So if you got that, great. Anyone think they know the greatest common factor for B?
3x.
Yes. So what do I need to multiply 3x by to get 9x squared? 3x. And then what do I have to multiply 3x by to get negative 3x? Just negative 1. And if you put a star here, that 1 is often hard for people to see, but you could also think negative 3x divided by 3x is negative 1. And if you're unsure if your answer is right, you can always expand mentally or on another piece of paper to see if you get back what you started with. Okay, moving on to C. So right away I see that there's only a 1 with my first two terms, so I know that my number part of my greatest common factor is just going to be a 1. So now I'm looking at the variables. And there is an x in all three terms. So x is going to be part of my greatest common factor. And the smallest exponent is just a 1, so just x. And then if you look, y is only in one of the terms, so it can't be part of my greatest common factor. It has to be common to all of them. So then you got to think your exponent rules here. What do I have to multiply x by to get x cubed? It would have to be x squared. Okay, because x times x squared, remember there's 1 there, is x cubed using your exponent rules. Plus, what do I multiply x by to get x squared y? It would be xy. And what do I multiply x by to get negative 2x? Negative 2. Okay, for D, so for the numbers, I'm looking at 4, 16, and 12. So 4 would be the greatest common factor. M is in all of them. So M is part of my greatest common factor, but then I have to consider the exponents. The smallest one is M squared. So 4m squared is actually my greatest common factor. A lot of people, when they're first starting to factor, accidentally put 4m there. So always keep the exponents in mind. And what do I have to multiply 4m squared by to get 4m cubed? M. What do I have to multiply 4m squared by to get negative 16m to the fourth? Negative 4m squared. M squared times m squared is m to the fourth by exponent laws. And then what do I multiply 4m squared by to get positive 12m squared? It's going to be positive 3. And I don't need any m because there's already an m squared ending here, and that's what I'm trying to get. So that would be D factored using common factoring. E, it maybe looks hard because there's no numbers anywhere, but it's actually not too tricky because the greatest common factor is just A. A is the only thing in common with all three terms. Oops, put my equal sign on the wrong side. So A is common. Whereas X is only in one of the terms, Y is only in one, and Z is only in one. So A is our common factor. And then what do I multiply A by to get A times X? X. What do I multiply A by to get negative AY? Negative Y. And what do I multiply A by to get positive AZ? Positive Z. I'm going to start this one too. Some people have trouble with this one. Could someone tell me what they think the greatest common factor for F is?
2.
Yeah. Okay, so some people think 4 doesn't go into 6, and then they think, oh, the greatest common factor is 1, but it's not because 2 goes into both 4 and 6. So 2 is your greatest common factor. And then what do you multiply 2 by to get 4x? 2x, not just x. And what do you multiply 2 by to get negative 6? Negative 3. And then if you do look inside, 2x and negative 3 don't have any common factor other than 1. So you have done it right. Right, and now G is kind of one that would be considered hard because of the exponents, but as long as you apply the rule for finding the common factor and your exponent rules, you should be okay. So the greatest common factor for 6, 12, and 18 is 6. There's an A in all of them. The smallest exponent on A is A squared. And I'll just give you a minute to try to figure out what goes in the bracket based on that. Think it through. All right, check and see if you got your terms inside your bracket right. So what do I multiply 6a squared b to the 5th by to get 6a cubed b to the 6th? You've already got the 6. You need an a. And then what do I multiply 6a squared b to the 5th by to get negative 12a squared b to the 7th? Negative 2. You've already got a squared, so you don't need any a's, but you need b squared, because b to the 5th times b squared gives you b to the 7th. And then for my third term, I need positive 3, because 6 times positive 3 is 18. A squared times a squared gives me the a to the 4th. And the b to the 5th is already there. So that would be what you would get inside the bracket. And if you look, none of these 3 terms has anything in common other than a 1. So that's always a good check. For H, they have 7 in common, but X is only in 1 term, so 7 is going to be your greatest common factor. And then you think to yourself, what do I need to multiply 7 by to get 14? That's 2. What do I need to multiply 7 by to get negative 7x? So it's going to be negative 1x, but you just need to write that as negative x. Okay, for I, see if you can figure out what the greatest common factor would be. Right, so hopefully you thought it was going to be 3m. 3 is the biggest number that goes into 15 and 9, and there's an m in the both of them, smallest exponent being a 1. And then what do you multiply 3m by to get 15m squared? 5m. And what do you multiply 3m by to get negative 9m? Negative 3. Greatest common factor for J. Greatest common factor of 5, 35, and 40 is 5. There's an x in all 3 of them. Smallest exponent is an x. And there's only a y in 1 and only a z in 1. So your greatest common factor should be 5x. What do I multiply 5x by to get itself? A 1. 5x times 1 is 5x. What do I multiply 5x by to get negative 35x squared y? Negative 7x, because x times x is x squared, y. What do I multiply 5x by to get 40xz? Positive 8, because 5 times 8 is 40. I already have an x, but I need a z. 5x times 8z is 40xz. And then again, none of the terms inside the bracket have a common factor with each other. So that means that you found the greatest common factor out front. So that's common factoring, okay? There's a couple of little extensions of it that we're gonna go through now. One of them is a binomial common factor. So these questions look difficult, but they're actually easier than the ones we just did. So keep that in mind. So what I want you to do is think of this as one big term in the question, and then this as my second term in the question. And I'm looking for, if this is one term, what it has in common with the other term. So here's the first term, here's the second term. What do they have in common? Well, they have a binomial in common. They have the binomial m plus 3 in common. So they have what we call a binomial common factor. So their common factor isn't a monomial like it was here. So single terms are called monomials. And normal common factoring questions work like that. But here the common factor is the binomial m plus 3. Okay, so that's my common factor. So then I'm thinking, well, what do I multiply this binomial m plus 3 by to get x times m plus 3? And I need to open up my bracket here. I multiply by x. So think about if I expanded that, I would get, before I expanded it out, using distributive property, I'd have these two things multiplying together, m plus 3 and x. Okay? Or you can think about the divide. If I don't know what I multiply m plus 3 by to get this part, I could think about dividing this big chunk by m plus 3, and those m plus 3s would cancel out, leaving me with just x. And then same thing here, if I mentally divide this big chunk by m plus 3, they cancel out and just give me -2. So really, I always think of this question as the binomial common factor is the common factor, and I call x and -2 the leftovers. The leftovers form the other bracket, and that's it, fully factored. So the same idea works here. There's two terms, but they're huge terms. So here's my first term, and here's my second term. And they have a binomial in common. And that binomial is a minus b. And then when you mentally divide each big chunk by a minus b, you're left with the leftovers in each part, in each chunk, and they form the other factor. So try C and D using that reasoning. I'll give you a couple of minutes to see if you can get them. They should just take one step.
If for C, since there's a minus, do you just put the minus in front of the 2m?
Nope, there's a -1 there.
Oh, so did you just like have a -1 then?
Yep, so your
Okay.
binomial common factor would be x minus 3. And the leftovers are 2m minus 1. Because that's really a -1. You just don't see the 1. And for D, the binomial common factor is x plus 5. And the leftovers are 4k minus 3. So that's called binomial common factoring, where the common factor is a bracket or a binomial rather than a monomial. And then another kind of extension is called factoring by grouping. Grouping is what happens when there's no common factor amongst all of the terms, and usually for grouping, there's 4 terms. So when you see 4 terms, you'd be suspicious that it's going to be a grouping question. So if you look through all 4 terms, they only have a 1 in common. So test yourself on that. They don't have 2 in common. There's not an x in all of them. There's not a y in all of them. So there's only a 1 in common with all 4 terms. And 1's not considered to be a common factor because 1 always goes into everything. So what happens then is you want to common factor just the first 2 terms, and then common factor just the second 2 terms to start off with. Okay, so if I look at just what's in common with just the first 2 terms, hopefully you can see that 2 is in common with just the first 2 terms. So if you just common factor the first 2 terms for now, what do you multiply 2 by to get 2x? X. What do you multiply 2 by to get positive 2y? Positive y. So then in a grouping question, the sign that comes next, the sign in between term 2 and term 3 always goes next. So that plus sign goes next. And then you're looking for what's in common with the second two terms. So x squared and xy, what's the common factor? So 1's going to be the number, so I don't need to write that down. There's an x in both of these terms, and the smallest exponent on x is a 1. So x is the common factor of the second two terms. And then you say to yourself, what do I multiply x by to get x squared? X. And what do I multiply x by to get xy? Positive y. So that's the first step in factoring by grouping. If you do the first step right, what happens is it turns into a binomial common factor question. So these binomials should match if you did your first step right.
Will they always match, like 100% of the time if you do it
Yeah.
right?
Yeah, if you do it right, they're going to match. Yeah.
Okay.
So in this case, they match. We did it right. So x plus y is my binomial common factor. And the leftovers, 2 plus x, form the other factor. So that's how a grouping question works. All right, so we're going to move on to the next one. And again, there isn't an A in all four terms. There's not a P in all four, or a Q in all four, or a B in all four. So that's where you know it's a grouping. So you're going to look at first just what's in common with just the first two terms. And you see an A is in common with just the first two terms. And then figure out what you need to multiply A by. Hopefully you figured out it was P plus Q, and then the sign that comes next goes next. So don't, one common error is people forget to put a plus sign there and they just put an X, so it looks like everything's multiplying, but we still have an add here so far. And then what's in common with your next two terms is B. And then if you divide B out, you're going to get P plus Q. So if you did it right, you get the binomial common factor of P plus Q in this case, and the leftovers form the second factor. And C, I'm going to change. This one's a bit too grade 11-y, especially for remote learning, but I've got another one that's good. So replace C with x cubed minus 3x squared plus 2x minus 6. So again, I would be looking to see if there was a number that was in common with all four, but there's not other than one, and there's only an x in the first three. So since there's four terms, you would think, okay, I've got to do this by grouping. So I'm just looking at the first two terms and what the greatest common factor is. So there's definitely an x, but the smallest exponent with just the first two terms is x squared. So that's what's in common with the first two terms. And then what would you need to multiply x squared by to get x cubed? X. What would you need to multiply x squared by to get negative 3x squared? Negative 3. Sign that comes next goes next. And then what's in common with 2x and negative 6? 2. And there isn't an x in both, so 2 is your common factor. And then you think of, what do I need to multiply positive 2 by to get positive 2x? X. What do I need to multiply positive 2 by to get negative 6? Negative 3. So if you factored by grouping right, these binomials should match, which they do. So then you have a common binomial. And the leftovers form the other factor. And then just quickly make sure that your leftovers don't have anything in common, and they don't, other than 1, so you're done. So that's grouping. All right, so we're on our last question. So why is factoring so important? Well, for grade 10, it's because it allows us to change how a quadratic is written and convert it from standard form to intercept form. It will also help us later on when we solve second-degree quadratic equations. So that will be next time I see you guys. That week will pretty much be devoted to solving quadratic equations. So, but for this week, it's really important for changing from what we would call standard form here. So that's standard form. Notice that standard form is generally ax squared plus bx plus c. And since I don't see a plus c here, I'm going to say that the y-intercept is 0 just by looking at this. And then once I put it into factored form and draw the graph, this will be a good check for me. But according to what I see, the y-intercept should be 0. So it says sketch a graph of the quadratic function, rewrite it in intercept form. So to rewrite it in intercept form, you want to common factor here. So one important thing that we didn't see enough of was whenever there's a leading negative, when you're common factoring, you always make the negative part of your common factor. So just let me go to the back of a page for a second. So if you had like negative 6x squared plus 9x, and you were common factoring it, you'd want that negative, we call it a leading negative, to always be part of your common factor. So in this case, 3 is the biggest number that goes into 6 and 9, and x would be my greatest common factor. So now I'm thinking, what do I multiply negative 3x by to get negative 6x squared? And that would be 2x. And what do I multiply negative 3x by to get positive 9x? There you need to know that a negative times a negative is what gives you a positive. Okay, so that's a rule you might want to write down. Whenever there's a leading negative, include that as part of your common factor. So here I have a leading negative, so I'm going to include it as part of my common factor. And so 2 is in common with both of them. They both have an x, and the smallest exponent on x is a 1. So then just like the one I just showed you on the paper, what do I multiply negative 2x by to get negative 2x squared? X. And what do I multiply negative 2x by to get a positive 8x? Well, a negative times a negative is going to give me a positive 4. So negative 2x times negative 4 is positive 8x. This sign thing is so important, and it's a really big common error. Now I want to remind you that intercept form looks like this. And that was similar to one of the questions that we got on the assignment yesterday, where we got just an X, and everyone was really great at changing that plain X to an X minus 0, which was awesome. So this one here is called factored form. And this is called intercept form. Okay, they're close. They mean the same thing. This one just exaggerates so that the intercepts jump out at you. So you can see that the intercepts are 0 and 4. So we were right on this one. And then we can calculate the vertex, because that's what we've been working on the last couple of days. So our h coordinate of our vertex is going to be 0 plus 4 divided by 2, which is 2. And k is going to be, so go back up to here, -2, replace x with h, replace this x with h, which is 2, and then calculate it through. So we get k to be +8. So we know our vertex is at 2, 8, h and k. And then we know our step number is -2. So if a is -2, that means our step is down 2, 6, and 10. Over 1, down 6 hits me on my intercept. And then down to 10. And then we've drawn in our parabola. So that's the purpose of factoring. And our unit on factoring is going to be to connect it to going from standard form to vertex form. The second type you're going to learn this morning is going to have a number in the C spot. Okay. Right. So that's the lesson on common factoring. I'm going to stop recording and then just talk to you guys for a minute, and then you can go and work on the practice. I want to